I think it might also be useful. I'm going to calculate the distance from A to D. And then what is the distance from A to D? It's 11, okay? Now, everyone can see now which these two circles are not touching each other, okay? I think everyone. Wow. All right, let's try the following then. What happens if I move this circle closer here? Are they touching each other then? But what is happening to the distance of AD? It's getting smaller, okay? Okay, let's do this thing.
Yes.
Are they touching each other? Okay, they're touching each other now, yeah? Are they touching each other? Now, what can you tell me about the distance of AD? It's equal to? It's equal to sum of the radius. Okay, what if I push this a little bit further? Are the circles still touching each other? How many times are they touching each other? They're touching each other 2 times. Okay. Now, what is happening here? What happened to the distance of AD? Now, what can you tell me about the distance? Let's try this again. Let's look at this. So, how many times are they touching each other here? They're touching each other once. If they're touching each other once, what should you see when? What is going to convince you with the circles are touching each other once? What is it that you should see? The distance? Yeah, the distance between center A and center D, yes. Is equal to the sum of the what of their radius. Now, what happens if the circles are not touching each other? What do you observe then? The distance between the two centers is greater than the sum of the radius. Okay? Come here and then talk about what we just saw. We are going to prove whether two circles are intersecting with each other, and then we came up with a guess to say this is how we're going to see it. Okay? So how are we going to see it? We're going to see it this way. Number one, if the distance from the centers are distance from the sum of the radius, then we know which these two circles are going to be touching each other once. Okay? That's the first one. So if the distance from center A to center B is equal to R1 plus R2, then we know which these two circles are touching each other, but they are touching each other. And then number two, if it happens which the distance of the two centers, the distance from center A to center B is smaller than R1 and R2, it means with the two circles are going to be touching each other how many times? 2 times. Then it means if the distance between center A and center B is bigger than R1 plus R2, the sum of the radius, then it means these two circles are not what? Not touching each other. So based on what we just learned, man, we can then come and do the following. Then we can try to determine whether or not these two circles are going to touch each other. Now, what should we see? What are the things that we need so that whether you'll be convinced with these two circles are going to touch each other? Number one, we need the centers. Okay? Can you get the center of these two circles? So we'll give them names. So I'm going to call this one center. I'm going to call this one circle with the center A. I'm going to call this one a circle with center B. Okay. If I call them that, these two, I want to know which are they going to touch each other. Now I need to know what is going to be the center of A. What is going to be the center of A? We know how to get that. What is going to be the center of A? It's -2 again. Is to what? Is to 4. Okay, so we have -2 is to 4. Then what is going to be the center of circle B? So B is going to be 5 is to what? Is to -4. Okay. No problem. What else do we know how to get from the previous activity that we're doing? We know how to get the radius. I can get the radius of this circle. And then I can also get the radius of this circle here. So let me start by getting the radius of circle A. If I get the radius of circle A, I'm going to say that R squared is going to be equal to 25. Okay? Then what is going to be R? Root and root. Okay? It says which R is going to be equal to what? To 5. Now I'm going to get the radius of circle B. How do I get that one? I'm going to say which r squared is going to be equal to 9 again. And I say root, and then I say root. It says which r is going to be equal to what? To 3. Now, based on what we just saw, we saw which we need the sum of the radius. Okay? We need to know what is going to be the sum of the radius. So what is going to be our sum of r? So I'm going to say the sum of our r is going to be given by 5 plus 3. Now, this doesn't say anything. We still want to know whether the circles are going to touch each other or not touch each other. What else do I need so that I can conclude this this question here? What else should I know? I should know the distance between A and B. Okay? So how do you calculate the distance between A and B? You're going to use the distance formula. So let's use the distance formula to do that. So if we use the distance formula, we know which the distance formula says D is going to be equal to root. And then it says x minus, it says x2 minus x1 all squared plus y2 minus y1 all squared. And then you can come and say AB is going to be given by, now if you are given the distance, we come and put B here. B is given as minus 5. It's 5, positive 5. So B is 5 is to minus 1. Now we do it alphabetically. If we do it alphabetically here, we'll come and say, okay, this one here is going to be x1. Now x1 goes with y1. Then this one here is going to be what to be y1. And then after that, you can say this one here is going to be what to be x2. And then this one is going to be y2. Now, based on what we just chose here, you come and substitute. Based on what we just chose here, what is going to be our x2? Then we're going to say this is 5 minus open bracket. Again, this negative comes from here. So you have minus open bracket. What is going to be our x1? Then you're going to have minus 2 close bracket, or you actually I've opened this bracket and then I closed it again. I've opened this one, I need to close it again. Is it fine? And then I have plus, what is going to be y2? It's minus 1, minus from the formula again. And then after minus from the formula, then you are going to put a bracket. You open a bracket. And then what is going to be your y1? It's 4. Close bracket, you close your bracket, and then it's what? It's squared. After that, you take out your calculator. On your calculator, you're going to type this thing exactly the way as it appears. So you have 5 minus open bracket minus 2. You close the bracket, and then you square it. Plus minus 1 minus open bracket 4, close the bracket, and then you square it again. And then it says which you're going to get what? Square root of 74. We don't know what square root of 74 is. So what are we going to do then? We're going to say, we want to know what is the answer here. We press ST again. It says which this is going to be 8,6. But the sum, what did we get the sum of R1 and R2 as? We got it as 1 as 8. Okay, based on what we know here, we say which AB, now we can see this. AB is greater than the sum of R1 plus R2. The distance between the centers is greater than the sum of the radius. Again, do the circles intersect each other? Yes or no? Do the circles intersect each other? Yes or no? No, because we said, look at the following. We said if the distance from A to B is greater than the sum of R1 and R2, then it means the two circles are not going to intersect each other.